This is section 8.4, more logarithmic equations. For log base b of x, b has to be greater than 0, which means it's positive. B cannot equal 1, and x is also greater than 0, which is also positive. That's really important to know. You might want to put this little box on your index card so that you can remember it. Example 1, solve. Log base 36 of x is equal to 3/2. Let's refresh our memory on the log form. Log base b of x is equal to y. Putting that in exponential form, that's b to the y power is equal to x. So in example 1a, we're going to put in exponential form. Anytime you have a log and it says to evaluate or solve, that means we need to put in an exponential form before we can solve. So the base is 36, my exponent is 3/2 is equal to x. Now, this is a rational exponent, and what do we do with a rational exponent? We put it in radical form, so let's refresh our memory on that. A to the 1 over n power is the nth root of a to the 1 power. So let's go over here and put 36 to the 3/2 power in radical form. That is the square root of 36 to the 3rd power. Now notice you don't have to put a little 2 inside the root. If you do, that's okay, but you don't have to. We're first going to take the square root of 36 is 6, and then cube 6 is 216. Example 1b, log base 9 of x is equal to 3/2. We're going to put that in exponential form, so that's 9 to the 3/2 power is equal to x. We're going to then put it in radical form. That's the square root of 9 to the 3rd power. Square root of 9 is 3. 3 to the 3rd power is 27. Example 1c, solve. You pause the recording and you do this yourself and see if you get the same answer. (16 to the 5/2 power, which is the square root of 16 to the 5th power. Square root of 16 is 4. 4 to the 5th power is 1024. If b is a positive number other than 1, remember that. Log base b is a positive number and it cannot be equal to 1. If you have 1 log base b of x is equal to log base b of y, then you just take the logs away and x is equal to y. For example, log base 5 of x is equal to log base 5 of 8. If the logs are identical, the logs just go away and you get, or the log base 5 goes away and you get x is equal to 8. Let's look at example 2. Solve and check. The logs go away, so we get x squared minus 4 is equal to 3x. Now the direction says to solve. We have to think about this. Because of that x squared, that's telling me that we're going to have 2 answers. Well, x squared is also a quadratic. A quadratic is, to get the 2 answers, we have to factor. Before we can factor, we have to have the equation equal to 0, and then we can factor. So we've got to put this in standard form, which is ax squared plus bx plus c is equal to 0. So we got to move that 3x on the other side. So we're going to subtract 3x on both sides. And then this is a trinomial that we're going to factor into 2 binomials. And then solve x is equal to -1 and x is equal to 4. Now it's very important that we check. We're first going to plug in -1 in for x into the original problem. So that's log base 2 of x negative 1 squared is a positive 1. 1 minus 4 is okay, so on the left side, we're going to combine 1 minus 4 is negative 3. So that's log base 3 of negative 3 is equal to log base, that should be a log base 2. Now notice, remember, that x cannot be a negative number. It must be positive. And right here, my x is a negative 3. So that does not work. So we cannot use negative 1. So we're going to scratch it out. Now let's try the log base 4. Let's try x is 4. We're going to plug it into the original problem. So 4 squared is 16. 16 minus 4 is 12. Is equal to log base 2 of 3 times 4 is 12. Left side equals right side, so it checks. So 4 is my answer. Example 2, the logs go away. Because if you have a log base whatever on one side equal a log base something on the same on the left, on the right side, the logs go away. So we just get x squared minus 15 is equal to 2x. We're going to put this equal to 0. And then we're going to factor. So x is equal to negative 3 and x is equal to 5. Now, let's check. Don't assume that just because x is negative 3, we cancel out negative 3. We have to plug it into the original problem and see if, when we plug it in, if the left side, if your log base b of x turns into negative, then we have to disregard it. So we're going to plug in negative 3. So that's log base 3 of negative 3 squared is 9. 9 minus 15 is negative 6. I can stop right there. Remember that you cannot have log base b of x. X cannot be negative, and it is, so we are going to scratch out negative 3. Now let's test 5. Sorry, I didn't mean to write on top of everything. So it checks. So 5 checks. Now this is not like, example 2c is not like example 2a and 2b. It doesn't have a log equal a log. So what are we going to do here? We are going to put it in exponential form. So that's x to the 4/3 power is equal to 81. Then we're going to put it in radical form. Now, there's two things that's happening to the x. I'm taking the cube root and I'm doing it to the 4th power. I need to get rid of one at a time. What is the opposite of taking the cube root of something? Cubing it. In rule of algebra, if you cube it on one side, you must cube it on the other. So then we get x to the 4th is equal to 531,441. And then we're going to take the 4th root of both sides, plug it in the calculator, we will get 27. Okay, pause the video for just a minute and copy all of this down. Okay, log base b of x is greater than log base b of y. If your logs are on each side, the logs go away and you just get x is greater than y. But look at the middle one. It says log base b of x is greater than y. Then we're going to put it in exponential form. B to the y power is less than x. Right there, you got to notice that we flip the inequality. Because your x and y switch sides, your inequality switch sides. Notice it is pointing to the y and it's open to the x. We have to keep it pointing to the y and open to the x. And then the last one, log base b of x is less than y. We're going to put that in exponential form. That's b to the y power. We have to flip the inequality to keep it still open to the y pointing to the x. So we had to flip that. So make sure you put a note. This is where people are going to mess up. Example 3a. Log base 3 of x is greater than 4. To put that in exponential form, that's 3 to the 4th power. Now don't forget, we've got to flip the inequality. Is less than x. Notice it's open to the x. The inequality is open to the x, pointing to the 4. To keep it open to the x and pointing to the 4, we have the x and the 4 flip sides, so we have to flip the inequality. 3 to the 4th power is 81 is less than x. And remember that anytime you have a variable, you always have to have the variable on the left side. So we're going to have to pick this up and turn it completely around to say x is greater than 81. Let's do a quick little number line. That's 81 all the way to infinity. So we've got to put it in interval notation, which is 81 to positive infinity. Example B, we're going to put that in exponential form. That's 4 to the 3rd power. And again, we're going to have to, the x and y are switching sides. So we're going to have to flip the inequality to say less than or equal to x. So that 64 is less than x. So we got to flip that around to say x is greater than or equal to 64. Put that in interval notation. We're going to graph it real quick. That's to the right. So in interval notation. Now, because it's a closed circle, we're going to close in our circle and put a bracket, not a parentheses. Example 3, solve. Put this in exponential notation. That's 2 to the 4th power. Again, we're going to flip the inequality to say greater than x. 2 to the 4th power is 16 is greater than x. We're going to flip this around to say x is less than 16. Now let's take a quick little look at the graph. It's less than 16, so that's all values to the left. Well, what is to the left? Negative numbers. And remember that log base b of x, x has to be a positive number. So, when will it start being negative? At 0. So we cannot go past 0. So this is saying x is between 0 and 16. And then we put it in interval notation, which is 0 to 16 with parentheses. Now, if you go to check your answer in the back of the book, it's going to be written like this. But remember, we always answer it, give both answers. Give the inequality notation, which is this, and then give the interval notation, which is that. Okay, let's look at example D. Put it in exponential form. Flip the inequality. Now that 4 to the negative 2, that's 1 over 4 squared. We're going to flip the x to be on the left side, and we're going to evaluate 1 over 4 squared is 1 over 16. Now let's do a quick little number line. Here's 1/16, and it's going to go to the left. But remember, it can't go past 0, because past 0 to the left of 0 are negative numbers. So that's inequality notation, to put it in interval notation. Okay, let's look at example 4. The logs go away, so we're going to put x plus 3 is greater than 2x plus 1. Now notice we just have an x, so we need to solve for x. Get x on one side, whole numbers on the other. Now I know what you're thinking. You want to subtract x on both sides, but remember, when you have an inequality, x needs to be on the left side. So I'm going to go ahead and move the 2x first. Then I'm going to subtract the 3. Negative 1x is greater than negative 2. Remember, when you divide by a negative number, you must flip the inequality, so that's x is less than 2. Let's do a quick little number line. Now, here's where it gets a little complicated. It's just not log base 4 of x. It's log base 4 of x plus 3. So at what point can we give x that it's going to be less than 0? Because remember, we want it to be greater than 0. So I'm at greater than 0. So let's take out x plus 3 and put it greater than 0 and solve. So when x is greater than 3, everything is going to be positive. But if it's less than -3, it's going to be negative numbers. And remember, we can't have negative numbers. Now let's look at the right side of the equation. We're going to have to look at the 2x plus 1 and put that greater than 0, because that's what we want. We want it to be greater than 0. Solve. So x is greater than -1/2. Let's put that on the graph. Okay, so right here, it's x is less than 0. However, when does it start being negative numbers? At -1/2 or at -3? It starts at -1/2. So we cannot go past -1/2. So to put it in inequality notation, x is between -1/2 and 2. And then put it in interval notation, that's -1/2 to 2. So that's a little tricky. Got to be careful about that. Okay, let's do example B. The log base 5's go away, so we're going to put 2x plus 1 is less than or equal to x plus 4. We're going to solve for x. So that's x is less than or equal to 3. We're going to graph it. Okay, now, it's less than 3, but at some point, when we plug in some numbers for x, we're going to get negative numbers. How do we find where they start becoming negative? Well, we put each side of the inequality. We're going to put the 2x plus 1, and we're going to put it greater than 0 to find out when it starts being negative. So at -1/2, x has got to be greater than -1/2. Anything less than -1/2, you start getting negative answers, and you cannot have negative answers. And look on the right side, x plus 4, that's very easy to see. It's starting at -4 is when it starts being negative numbers. So let's graph these two numbers on the number line. There's -4, there's 0, there's -1/2. And it's the one on the right. If you're trying to figure out which one, from 3 to the left, where does it starts being negative at -1/2. So there's the graph. You try to do example C. So turn off the video, you try to do example C, and then turn it back on and check your answer. Okay, let's do this example. The log base 5 go away. So we get x is greater than 3. Let's draw a number line. Because it's greater than, it's all to the right. So we didn't have to worry about any negative numbers because it's greater than 3. And had it been a less than 3, that would have been a whole nother case. But because all values that are to the right of 3 are all positive, so we're in good shape. Okay, try these two practice problems. Okay, let's try one more. Okay, values that are small to the left of 32, we have to stop at 0.